Chapter 2, Lesson 5, Percent of Change. Essential question. How can percent help you understand situations involving money? Vocabulary. Percent of change, percent of increase, percent of decrease, and the percent error. Real world link. We have a speed racer. The Indy 500 is one of the world's greatest motor races. The table shows the average speed of the winning of the winning race cars for various years. In year 1922, the speed was 94 miles per hour. 1955 was 128 miles per hour. In 2010, it is 162 miles per hour. So for the first step, we're going to write the ratio, which is the speed increases from 1922 to 1955, divided by the speed in 1922. We will then write the ratio as a percent and round to the nearest percent. So if we take the information of the speed increase from 1922 to 1955, that's the same thing as doing 128 minus 94. That gives me the answer of 34. So the speed increase from 1922 to 1955 is 34 miles per hour out of the original speed of 94 miles per hour. When I take 34 divided by 94, that gives me the percentage of 36. 36%. Now 34 divided by 94 is not exactly 36%. 34 divided by 94 gives me the answer of 0 and 3617. It keeps going from there. So when I multiply this by 100, that gives me 36 and 1700ths of a percent. But it says round to the nearest whole percent, so that's how I got 36%. Number 2, write the ratio of the speed increase from 1955 to 2010 in my numerator, divided by the speed in 1955. Well, we're going to then write the ratio as a percent and round to the nearest whole percent. So I'm going to take 162 and subtract it by 128. That gives me the answer of 34. Divided by the speed in 1955, which was 128. So if I do 34 divided by 128, that gives me the decimal of 0 and 265625. Multiplying that by 100, that gives me 26 and 6/10%, which is approximately 27%. So why are the amounts of increase the same, but the percents different? Well, this is because the speeds for the starting years are different. Continuing. The key concept is the percent of change. The words, a percent of change is a ratio that compares the change in quantity to the original amount. So the equation is the percent of change equals the amount of change divided by the original amount. So when you compare the amount of change to the original amount in a ratio, you are finding the percent of change. So from above, I'm going to actually highlight the equation. The percent of change percent of change equals the amount of change divided by the original amount. So the percent of change is based on the original amount. If the original quantity is increased, then it is called a percent of increase. So original quantity is increased, it's called the percent of increase. If the original quantity is decreased, it is called the percent of decrease. So the percent of increase has the amount of increase divided by the original amount. The percent of decrease is the amount of decrease divided by the original amount. So let's try practicing this. Example 1. Find the percent of change in the cost of gasoline from 1970 to 2010. Round to the nearest whole percent if necessary. Well, if we compare our price of gas in 1970, that is $1.30. Well, in 2010, it was $2.95. So we know that this is going to be a percent of increase because our value goes up from from $1.30 to $2.95. So we're going to start with step 1. We're going to find the amount of increase. So if it is $2.95 in 2010 and $1.30 in 1970, I'm going to subtract these two values. That gives me $1.65. So that was step number 1. Now let's try step number 2. That is going to be finding the percent of increase. So I use the percent sign instead of writing out the word percent, just as shorthand. It's up to you if you want to do that. So I'm going to take $1.65, which was my percent of increase, and divide it by my original amount of $1.30. So I'm going to do amount of increase, so I'm using my arrow for increase, divided by the original amount. So 165 divided by 130 is about 1 27/100. When you multiply that by 100, that gives you 125%. So this means the percent of increase from 1970 to 2010 is 127%. Let's continue. Number 2, Yusuf bought a DVD recorder for $280. Now it's on sale for $220. Find the percent of change in the price. Round to the nearest whole percent if necessary. Well, if we know that he paid $280 and now it's on sale for $220, then this means that this is going to be a percent of decrease. And again, we know that it's a percent of decrease because it goes from a larger amount to a smaller amount. So I'm going to take 280 minus 220, which equals 60. So again, I know that it's going down by 60. And again, it's a percent of decrease. So now we're going to find that exact percent of decrease by taking our amount of decrease, divided by the original amount. So the amount of decrease was 60 divided by original amount of 280. That gives us about 0 21/100. Multiply that answer by 100, and that equals 21%. So the price of the DVD recorder decreased by about 21%. All right, let's see if we got it. We're going to do these two problems to find out. Letter A. Find the percent of change from 10 yards to 13 yards. Well, I know that it's going to be a percent of increase because to go from 10 to 13, that's an increase. So I'm going to find my amount of increase. 13 minus 10 is 3. Then I want to set up my proportion with the amount of increase divided by the original amount. So 3 divided by 10. Well, 3 divided by 10 is 3/10. Multiply that by 100, that is going to be 30%. So it's going to be a 30% increase. Again, I'm using the arrow to represent the word increase. You could also write out the word increase if you would prefer. Letter B. The price of a radio was $20. It is on sale for $15. What is the percent of change in the price of a radio? So if it was $20 and now it's on sale for $15, we know that this is going to be a decrease. So this is a percent of decrease. I'm going to label this with letter B. So I'm going to take 20 minus 15, which is 5, and find the amount of decrease divided by the original amount. So now I'm going to start abbreviating original amount OA, but I'm always going to say original amount. So that means 5 divided by the original amount of 20. 5 divided by 20 gives you 25 hundredths. Multiply that by 100, that equals 25%. So this is going to be a 25% decrease. So another key concept is the percent error. The percent error is a ratio that compares the inaccuracy of an estimate or amount of error to the actual amount. So the equation is the percent error equals the amount of error divided by the actual amount. So we're going to find the percent error is similar to finding the percent of change. Instead of finding the amount of increase or decrease, you will find the amount an estimate is greater or less than the actual amount. So suppose you guess there are 300 gumballs in the jar, but there are actually 400. Well, we're going to go ahead and compare the actual to the guess. So we're going to find the amount of error and divided it by the actual amount. Well, the amount of error is going to be 400 minus 300. And I'm going to divide it by the actual amount of 400. So that is a difference of 100 divided by 400, which is equivalent to 1/4. 1/4 equals 25 hundredths. So you multiply that by 100, that gives you 25%. So it has a 25% error. Continuing. Example 3. Ahmed wants to practice free throws. He estimates the distance from the free throw line to the hoop and marks it with chalk. Ahmed's estimate was 13 5/10 feet. The actual distance should be 15 feet. So we're going to find the percent error. So step 1, we're going to find the amount of error first. So if the actual amount is 15 feet and he guessed 13.5 feet, that is 1 5/10 feet that Ahmed is off of. So step 2, we're going to find the percent error. In order to find the percent error, that is going to be the amount of error, which is what we solved in step 1, divided by the actual amount. So the amount of error is 1 5/10, while the actual amount is 15. Well, to solve 1 5/10 divided by 15, that is 1 10 hundredths. 1/10. When you multiply that by 100, that is equivalent to 10%. So the percent error is 10%. Well, let's see if we got this. We're going to do this problem to find out. Find the percent error if the estimate is $230 and the actual amount is $245. We're going to round to the nearest whole percent. Well, step 1 is to find the amount of error. So I'm going to take the actual amount, which is 245, and subtract it by the estimate of 230. That gives me 15. Step 2 is to find the percent error. Percent error is the ratio of the amount of error divided by the actual amount. The amount of error is 15 divided by the actual amount of 245. So when I go in and I find 15 divided by 245, that gives me 0 and 0.612. It continues from there, but I'm just going to use this. Multiplying that by 100. To the nearest whole percent, this is a 6% error. 6%